1-3. Now let's talk on relation between sets. Between sets. Like when we write down this, what is this? X is a subset of Y. X is a subset of Y. In terms of notation, we can write down for any X and set of X. For any X and set of X, there is an X and set of Y. For example, X is equal to 1, 2, 3. But Y is equal to 1, 2, 3, 4, 5. Now, X is a subset of Y because for any X that included in this capital X, in this set, we have an X in this here, in this set of Y. 1, 1, 2, 2, 3, 3. But it doesn't mean that any number that included in Y should be included in X. And also we have equal sign or another relation between two sets, which X is equal to Y. It means set X is equal to set Y. It means for any X included in X, there exists an X in Y. And also for any X in Y, there exists an X in capital X. For any X in set of X, there exists an X in Y. For any or for every X in Y, there exists an X in X. For example, set of X is equal to 1, 2, 3, 4. And set of Y is also equal to 1, 2, 3, 4. Then those two sets are equal because all the elements that we have in X, we have in Y. Or in another way, all the elements that we have in Y, we have in X. That's why these two sets are equal. 1-4. Operation of sets. Like when we have X with this notation, Y, it means X intersect Y, or intersection of two sets. X intersect Y, or it means intersection of two sets. We can write down this one as a set of X such that X in capital letter X in set X, and there is an X in set Y. For any X, this intersection means set of X such that for X in X and X in Y. For example, we have this set X, we have this set Y. This is one element, this is another element. For example, 1, 2, 3, 4, 5, 6. And in set Y, in set X, we have 1, 2, 3, 4, 5, 6. And in set Y, we have 5, 6, 7, 8, 9. Then the intersection of these two sets are the numbers that we have at the same times in both. we have x in x and we have x in y. The x, all the x that we have in x, and also those x that we have at the same time in y. So intersection of x and y is a set of which numbers? 5 and 6 that we have at the same times in both set. This is the intersection of the set. This one is union of the set. And we can write down by this way. X such that for any x or for x in set of x, or for x in set of y. Again, with the same example, the union of these two sets are all the numbers that either we have in x or in y or in both. So then the union of these two sets become one that we have in set x, 2 that we have in set x, 3 that we have in set x, 4 that we have in set x, and 5 and 6 that we have at the same time at both, and also 7, 8, and 9 that we have only in set y. So this is the union of two sets. And also we have this sign, which means difference between two sets. This sign, or we write down by x minus y. It means that the element that we have in x but we do not have in y. Which element that we have in x but we do not have in y? 1, 2, 3, 4. 1, 2, 3, 4. This 1, 2, 3, 4 is the difference between set of x and set of y. Or we can write down y difference x. It means y minus x. Any element that we have in y but we do not have in x. Which one is that? 7, 8, 9. These elements we have in y but we do not have in x. So this sign can be used for difference, either this sign or either negative. Anyone we can use. It's 1, 5. N-tuples and Cartesian product. N-tuples means in each element of the set is combination of n other sub-element. For example, an element of a set is started from x1 up to xn, or a product or multiplication of different values from x1 to xn. Then a Cartesian product that we can write down by sign of pi, which is start from I equal to 1 up to n for xi, is equal to n tuples start from x1 up to xn, such that for each xi and set of xi, and for every I from 1 to n. If we, for example, think about n just equal to 2, n equal to 2, then this Cartesian product will change to xi from I equal to 1 to 2. Then we have only a vector of two elements, which is equal to x1 and x2, such that xi and xi for every I equal to 1 and 2, because we have only two x, which is we start from 1 and we move to 2. Like this one, we can easily write down in a graph. Actually, this n shows the dimension, how many dimensions we have. If n is 2, it means we have only 2 dimensions, x1 and x2. For example, let's see, this one is x1. x1, suppose this one x1 0, and starting point. This one x2 0. A Cartesian product of this one become this point, which sometimes we write down in a like bold x. In a bold x, which this bold x is equal to x1 0 and x2 0. You can write down also x0, because it's, for example, just suppose this is the starting point, that we start from x1 0 and x2 0 is this point, which is x1 and x2. So it's just like 2-dimensional. We have dimension of x1, we have dimension of x2. If we have n equal to 3, then we need one more dimensional here, for example. Then this one is x3. But mostly, in order to make simple, we just work with 2 dimensions. That's why when it comes to like utility function, we like suppose that there is x1 and x2, ux1 and x2. When it comes to like production function, we suppose that there is only labor and capital, in order to make it easier to draw in a graph.